Hello everyone, welcome to this YouTube channel, Mathematics and Me. Again, I am your virtual instructor. I am Miss Ikes Adonis. And for today's video, I am going to discuss to you the measures of central tendency or the measures of position for group and ungrouped data. So these measures of central tendency are mean, median, and mode. So let's start with a simple recall of what is statistics and what are the types of statistics. When we say statistics, it is a branch of mathematics that involves collection, organization, presentation, analysis, and interpretation of data. So in acronym, statistics is a mathematics or a branch of mathematics that involves COPI. COPI means collection, organization, presentation, analysis, and interpretation of data. So we have two types of statistics. First, we have descriptive statistics, and the second one is we have inferential statistics. So let's differentiate the purposes of the two types of statistics. When we say descriptive statistics, the purpose is to describe or tell something about the set of data or group. So again, in descriptive statistics, your purpose is just to describe or tell something about the set of data or group of data. While in inferential statistics, your purpose as a researcher or as a statistician is to use a sample to generalize results about the population. So, in simple word, descriptive statistics means describing the set of data, while inferential statistics means generalizing, predicting, or concluding about the population based on the used sample. So, let's have an illustration so that you can understand deeply and clearly what are the difference or what is the difference between descriptive statistics and inferential statistics. Okay, so as you can see in these two figures or in these two pictures, the difference is in descriptive statistics, the only shaded part is the sample. So it means that in descriptive statistics, you just describe the characteristic and the attributes of a sample. While in inferential statistics, aside from you describe the characteristics of the sample, you also generalize that these characteristics or attributes of a sample are also the characteristics or attributes of the whole population. So you are already predicting or generalizing that whatever the characteristics or attributes of a sample, that is also the characteristics or attributes of the whole population. So that is the difference between inferential and descriptive statistics. And let's look again about sample and population. When we say sample, it is only a part of the population. And there is a presence of randomly selected. And in selecting a sample, you use sampling procedure. Next is population. When we say population, it is the total possible respondents or participants in the study. Or it consists all the respondents or all the participants in the study. Okay, so we have different types of descriptive statistics. We have the measures of central tendency, which are mean, median, and mode for group and ungrouped data. And we also have measures of dispersion or measures of location, such as standard deviation, average deviation, range, percentile, quartile, decile, and others. And under inferential statistics, we have hypothesis testing. And we also have correlation and regression analysis, analysis of variance or ANOVA, multiple analysis of variance or MANCOVA, t-test, c-test, and then chi-square. So that are examples of inferential statistics. So for now, let's focus on the measures of central tendency. So when we say measures of central tendency, you are looking for a single value that will represent a data set. So measures of central tendency, you are just looking for a single value. And your purpose here is to locate the center of a set of data. So again, the three measures of central tendency are mean, median, and mode. So let's have the different properties of these three measures of central tendency. So let's have the first column for the properties of the mean, second column for the properties of the median, and third columns for the properties of the mode. So here in number 1, so in this first row, mean has only or in mean you have only one mean. While in median, here you only have also one median. However, in mode, you can have one or more than one mode. So if you have one mode, it is called unimodal. If you have two modes, it is called bimodal. And if you have more than two modes, let's say 3, 4, 5, or 6, you have multimodal. So that are the differences between mean, median, and mode in this first column. So next, wait, let's erase this. So next, let's have the second row. By the way, let's have the second row. So mean is applicable to interval and ratio type of data. Because as you can remember, we have 4 scales or 4 levels of data. We have nominal level, we have ordinal level, we have interval level, and we have also ratio level. But in this video, we will not discuss these 4 levels of measurement. So in mean, you can use the interval and ratio type of data. While in median, you can apply the ordinal, the interval, and ratio type of data. And in mode, you can apply all the types of data, the nominal, ordinal, interval, and ratio type of data. Number 3, or the third row, so all values are included in the computation of mean. No data or no value will be excluded in the computation of mean. While in median, you need to have an array before you can get the median. So if you are given an ungrouped data, specifically if the data are raw, you need to arrange it in increasing or decreasing order so that you can form an array of data. Because you cannot get the median of an ungrouped data if you will not arrange it in an array in increasing or in decreasing order. And in mode, it is an easiest average to compute because if you are given an ungrouped data, by just looking at the data or by just a glance, you can tell what is the mode or how many modes are there. Because a mode has the more frequency or has the more appearance of or has a more appearance in the given set of data. So, siya yung may pinakamaraming appearance, yung mode. Next, fourth row. So, this is the fourth row. So, min is very useful in comparing more than one groups. So, kadalasan ginagamit natin sa ating statistics is min. Siya yung kino-compare natin. Kadalasan, let's say for example, we have t-test. So, if we use t-test, we will compare two means. But if we will use ANOVA, we will confirm or we can compare 3 or more means. Okay, next is fifth row. Okay, in fifth row, the mean is affected by extremely large or small values or what we called outlier. So the mean is greatly affected by outliers. Not the same with the median because they are not affected by outliers. And mode is also not affected by outliers. Only the mean are affected. Because as far as I can remember, you use all the values in the computation of mean. So since you use all the values in the computation of mean, if there is an outlier, when we say outlier, an extremely large or an extremely small values, so that extremely large or extremely small values will affect the mean of the data set. Okay? Sixth row. So you cannot compute or mean cannot be computed with an open-ended class in FDT. While in median, you can compute with an open-ended class in FDT, and mode also, you can compute the data in FDT provided that the model class is not open-ended. And last row, number 7 or the 7th row, mean is more appropriate in symmetrical data. So kapag symmetrical data, it is more appropriate in a normal distribution or kapag normally distributed yung data. When we say normally distributed, we can draw a curve like this. So, this is a normal distribution of data because the mean is at the middle. However, in median is most appropriate in a skewed data. So, when we say skewed data, it is not normally distributed or yung data are not normally distributed. So, skewed data looks like this. Okay, so this is positively skewed while this one is negatively skewed. Okay, so I hope you get what I am saying. Okay, so let's proceed now in ungrouped data and grouped data. So when we say ungrouped data, the number of respondents or your N must be less than 30. But once the data already reach 30 or it exceeds 30, so N is greater than or equal to 30 na, or your respondent is 30 or greater than 30, you can now group the ungrouped data. So you can create a class interval like this. This is the class limits or the class intervals and the frequency in each class interval. Okay, so let's have an example here. These are the ages of math teachers. 53, 45, 28, 48, 46, 32, 24, 58, 55, and then 45. So we have the different formulas. So mean is represented by X bar. And the formula in finding the mean of ungrouped data is this. So X bar is equal to the summation of X all over N, wherein the X here is the ages, or the X here are the ages of math teachers. And N is the number of ages. So in this part, our N is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our N is 10. And to get the summation of X, we will just add all of these ages. Okay? Okay, so next, when we say median, so in median, again, you need to make an array of data before you can solve for the median. And you can find the median rank value using this formula, n plus 1 over 2. And for the mode is just the value with the highest frequency. So by just looking at the data, especially if it is an ungrouped data, you can now tell me or get what is the mode by just looking at the data. So let's have an example. 15 randomly selected education students were asked to state the number of hours they slept last Sunday. So the resulting data are 4, 5, 7, 8, 10, 5, 4, 9, 8, 11, 10, 8, 8, 6, and 7. So you are going to find the mean and the median and of course the mode. So first, you must arrange the row data in increasing or decreasing order before you find the mean, median, and the mode. Because you cannot find the median if you don't arrange the raw data into an array. So, to make it easier, we will arrange first the raw data into an array. So, it is arranged in increasing order. So, to find the mean, because mean is represented by X bar, the formula is, okay, so the formula is summation of X over N. So, if we are going to add all of these numbers, so it will total to 110. And divide by how many scores are there? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So our N is 15. So now, let's divide 110 and 15 to get the mean. So 110 divided by 15 is 7.333. So 7.33. So this is now the mean given this data. So did you get it? Okay. So next, let's find the median. So median is presented as X. Okay, so yung sa taas ni median na symbol is like this. Yung parang similar symbol. So, to find the median, first, you need to know what is N. So, a while ago, you know that N is equal to 15. So, since N is an odd number, so you will get the 8th term. Kasi the middle of 15 is the 8th term. So let's get the 8th term. So this is 1, 2, 3, 4, 5, 6, 7, 8. So this is the 8th term. So let's check whether 8 is really the middle of 15. So let's count here. 1, 2, 3, 4, 5, 6, 7. Okay, so in left, you have 7 numbers, and in right, you have also 7 numbers. So your median is 8. However, what if your n is an even number? Let's say I will add here another 4 before the two fours. So if your n is equal to 16, so you have two numbers at the middle. And that are the numbers 8 and 9. Okay, so let's count. So if you have 16, we have 1, 2, 3, 4, 5, 6, 7, 8. So this is your 8th term. So you have 7 data. 1, 2, 3, 4, 5, 6, 7. So as you can see, you have also 7 numbers in the left and 7 numbers in the right. So it means 7 and 8 are the middle numbers. So to get the median, if your n is an even number, to get the median, you will add the two middle numbers. So you will add 7 and 8, 7 plus 8, and divide it by 2. So 7 plus 8 is 15, and 15 divided by 2 is 7.5. So it means that the median is 7.5. If there is another 4 in this data. However, in our problem, the given is just that data. So there is no 3 4s. So we will remove this. Let's remove this because our median here is 8 because our n is 15. Okay, next. So let's find the mode. Mode is presented by this x and yung parang pakubyang symbol. So the mode is the number with higher frequency or many appearance. So what do you think is the mode? Yes, you're right. It is 8 because we have 4, 8. So our mode here is 8. Okay? So did you get the process in finding the mean, the median, and the mode given that the data is ungrouped? Okay. So I hope you get the process in finding the mean, median, and mode of ungrouped data. Okay, so let's start now with a group data. So when we say group data, we have also different formulas. So this is the formula for the mean. This is the formula for the median, and this is the formula for the mode. Okay, so let's have an example. Below is the frequency distribution table of the scores of STEM students in math tests. So you are going to determine the mean, the median, and the mode. So let's find first the mean. So given this table again, so this is the table, the sample problem. And we are going to find the mean. So the formula in finding the mean is this one. X bar is equal to the summation of f of x over n, wherein summation of f of x is the sum of the product of the frequency and the data. And n is the sample size. So to find the mean in the group data, we have the following steps. First, step 1, the frequency column is your F. So this is your frequency column. And it is already given in our table. And notice that there is still no X column. So since there is no X column, you are going to find the midpoint of each class interval. So to find the midpoint of each class interval, you will add the two values, the lower limit and the upper limit, and divide it by 2. So, for example, given this interval 18 to 26, so we will add 18 and 26. So, 18 plus 26 and divide it by 2. So, the answer is 22. Therefore, the midpoint in this class limit or class interval is 22. So if you will continue the same process, you will get these values. Again, 27 plus 35 divided by 2 is 31. 36 plus 44 divided by 2 is 40. 45 plus 53 divided by 2 is 49. So that is how we get the midpoint or this column. Okay, so since you have now the midpoint, you can now get the product of F and X. So you will just multiply this 3 and 22 to get 66. So 3 times 22 is 66. 5 times 31 is 155. 9 times 40 is 360. So just continue the process. You will get this F of X column. So now, let's get the summation of f of x. So you will just add this. 66 plus 155 plus 360 plus 686 plus 638 plus 402 plus 102, we have 2,402. So this summation of f of x can be substituted to this summation of f of x. So we have 2,409 divided by n, which is 50. So our mean is 48.18. So for interpretation, the mean score of the students in a math test is 48.18 or 48 if it is rounded off, since the scores are whole numbers. So this is now the mean given this problem or given this table. Okay, next. Let's find the median. So again, you are given the same problem or the same table. And this is now the formula for median, wherein LB is the lower boundary of the median class, N is the sample size, less than CF is the cumulative frequency before the median class, F is the frequency of the median class, and I is the interval. So we have also the steps in finding or solving for the median of the group data. Number 1 or step 1, you are going to construct the cumulative frequency column or the less than cumulative frequency column, or just the cumulative frequency column. And then, adding the two consecutive values and F and CF, you can get the other cumulative frequency. So, here, this part is already given. This is this part. So, paano makukuha or how can you find CF? First, you copy frequency 3 as the first CF. Next, you add CF and F. So, you add 5 and 3, we have 8. You add 9 and 8, we have 17. You add 14 and 17, we have 31. You add 11 and 31, we have 42. Add 6 and 42, we have 48. And add 2 and 48, we have 50. So that is how we get the cumulative frequency column. Okay, second step, you are going to determine the median class. So to determine the median class, we have the median class formula to find the median class. So this is the formula to find the median class. So we have n over 2. So we will just divide the n, which is 50, by 2. So we have 25. So after you get 25, the median class is the one containing the 25th rank. So this is the fourth row found before and nearest to 31. So what will be your basis in finding the median class? Take a look at this. So you have 25 or you get 25. So saan nag-fall si 25? It is ba sa 3, sa 8, sa 17, or sa 31? Of course, it falls in this in this class because it is in increasing order. So, it will not fall here because kulang siya. Hanggang 17 lang siya. 17 is the maximum. So, this class started with or starts with 18 to 31. So, from 18 to 31, it means 25 fall in this class. Okay. So, now, let's solve for the median using the formula. So, in number 3, you are going to apply this formula. So, given the median class, this is the median class, you will get the important numbers in this formula. So, you will get the lower boundary, you will get n, you will get less than cumulative frequency, you will get f of the modal of the median class, and you will get the class size I. So, let's substitute. LB is the lower boundary of the median class. Again, this is the median class. So, the lower boundary is 45 minus 0.5. To get the lower boundary, you will always subtract 0.5 to whatever the number here. So, the lower boundary here is 45 minus 0.5. So, our lower boundary is 44.5. So, substitute the givens. 44.5 is our lower boundary. N is 50. And your less than cumulative frequency is 17. Why 17? Because less than CF is the cumulative frequency before the median class. So, the cumulative frequency before the median class is 17. So, by simplifying this, we will find the median equal to 49.64. So, the median or the middle score of the students in a math test is 49.64 or 50 because we are going to round off since the scores are whole numbers. Okay? So, next, let's have the mode. So, to find the mode, the first step is you are going to locate the modal class. It is easier to locate the modal class. Unlike dun sa median class. So, sa median class, you are going to use the formula n over 2 to get the median class. However, dito sa mode, you can find the modal class by just simply looking at the frequency. So, whichever class interval has the higher frequency or the highest frequency, that will be the modal class. Since 14 is the highest frequency, therefore, this will be your modal class. Okay, so next step, you will solve for the mode using this formula. So L sub MO is the lower class boundary of the modal class. F of MO is the frequency of the modal class. F sub B is the frequency before the modal class. F sub A is the frequency after the modal class. And I is the interval or the class size. So now, let us now substitute. So again, here, your LMO is 44.5. Your FMO is 14. Your F sub B is 9. And your F sub A is 11 and I is 9. So by substituting it to the formula, we get the mode equal to 50.31. So interpretation for this is the mode score of the students is 50.13 or simply 50 because most of them got a score of 50. So this is the interpretation. Since the mode is 50, it means most of them got a score of 50. Okay, so thank you everyone for listening. By the way, I have here activity number 1. You can give the answer in the comment section below and then stop the video so that you can screenshot this activity. And the next activity given a group data.